There's a planet 63 light-years away that's so hot it's raining liquid iron. Its atmosphere is 4,000 degrees Fahrenheit. Winds reach 11,000 miles per hour. And every night, molten metal condenses from clouds and falls like rain. According to every physics model we have, this planet shouldn't exist. But it does. That's WASP 76b. And it's not alone. We've discovered planets that violate fundamental laws of planetary formation. Worlds that exist in orbits that should be impossible. Objects that challenge everything astronomers thought they understood about how solar systems work. These aren't theoretical problems. These are real planets, observed by telescopes, defying physics. Planet 1. HD 1. 8973. The glass storm planet distance, 64 light-years from Earth. The problem? This planet has winds that reach 5,400 miles per hour, 7 times the speed of sound. And it rains glass. Sideways. Here's how insane this is. HD 189733b is a hot Jupiter, a gas giant orbiting extremely close to its star. It completes one orbit every 2.2 Earth days. One side permanently faces the star, heated to 1,700 degrees Fahrenheit. The other side, in eternal darkness, drops to 500 degrees. That temperature difference creates the most violent weather system we've ever observed. But here's what shouldn't be possible. The atmospheric winds move at 5,400 miles per hour. That's Mach 7. For comparison, Earth's fastest winds, inside tornadoes, reach maybe 300 miles per hour. Jupiter's Great Red Storm, the most powerful storm in our solar system, has winds around 400 miles per hour. This planet's entire atmosphere moves at speeds that would disintegrate any solid object. And then there's the glass rain. The extreme heat vaporizes silicate particles, basically sand. These particles get caught in the supersonic winds, blown to the dark side where temperatures drop, and condense into glass crystals. Then they fall, horizontally, at 5,400 miles per hour. Imagine standing in a hurricane made of glass shards moving at 7 times the speed of sound. Astronomers can't explain why the atmosphere hasn't been torn apart. At those wind speeds, the atmosphere should be ripping itself apart through friction. The temperature differentials should create turbulence that disrupts the wind patterns. But instead, HD 189733b maintains these impossible conditions continuously. The planet glows blue when observed through telescopes, not from water, but from silicate particles scattering light. It's beautiful. It's impossible. It exists. Planet 2. Kelt 9. The planet that's hotter than most stars' distance, 670 light-years from Earth. The problem? This planet is 7,800 degrees Fahrenheit. That's hotter than 80% of stars in the universe. It's so hot that molecules can't form. Hydrogen itself is being torn apart. Kelt 9b orbits a blue A-type star, one of the hottest star types. It's so close to its star that it completes an orbit in 36 hours. The planet is tidally locked, meaning one side permanently faces the star. That side reaches 7,800 degrees Fahrenheit. For reference, our sun's surface is 10,000 degrees Fahrenheit. This planet is nearly as hot as the surface of the sun. But here's where physics breaks down. At these temperatures, molecules shouldn't exist. Water molecules disintegrate at 2,700 degrees. Even metal molecules can't survive above 5,000 degrees Fahrenheit. Kelt 9b is hotter than that. Its atmosphere should be completely atomic, individual atoms, no molecular bonds at all. And the atmosphere is escaping. The intense heat causes atmospheric particles to reach escape velocity. The planet is evaporating. Astronomers calculate it's losing 10,000 to 100,000 tons of atmosphere per second. That's 1 billion pounds of gas escaping into space every 10 seconds. The planet has a massive tail of escaping gas stretching millions of miles behind it, like a comet made of hydrogen. Here's the problem. This planet shouldn't still exist. At the rate it's losing atmosphere, it should have been completely evaporated hundreds of millions of years ago. The star is only 300 million years old, relatively young. Either our calculations about atmospheric loss are catastrophically wrong, or this planet is far more massive than we can measure, or there's a mechanism replenishing the atmosphere that we don't understand. None of these options make sense with current physics. Planet 3, GJ 1214 Banfi, the water world. That shouldn't have water distance, 48 light-years from Earth. The problem, this planet might be completely covered in water. Not oceans on a rocky surface. The entire planet might be water, hundreds of miles deep. And at those pressures, the water should be in exotic forms that can't exist naturally. GJ 1214b is a super-Earth about 2.7 times Earth's diameter, but its density is too low to be rocky. Astronomers calculate that 75% of the planet's mass must be water. If true, this planet has an ocean 120 miles deep, covering its entire surface. Below that, extreme pressure creates hot ice, water compressed so hard it stays solid, despite temperatures exceeding 1,000 degrees Fahrenheit. But here's what violates planetary formation theory. Planets form from the protoplanetary disk around young stars. Close to the star, it's too hot for water ice to exist. Water stays as vapor. Farther out, past the snow line, water freezes and can be incorporated into forming planets. GJ 1214 orbits at 1.3 million miles from its star, well inside the snow line. There's no mechanism in our planet formation models for a water world to form there. The planet had to form farther out and migrate inward. But migrating planets interact gravitationally with the disk material. Those interactions should strip away the water atmosphere as the planet moves through the hot inner regions. By the time GJ 1214 Brett reached its current orbit, it should have lost most of its water. But it didn't. It's still there, hundreds of miles deep. And the pressure at those depths creates water types that shouldn't exist in nature. Below 120 miles depth, pressure exceeds 4 million psi. Water at these pressures forms ice Evans and ice X, crystalline structures that are solid despite extreme heat. Deeper still, pressure might create superionic ice, a state where oxygen atoms are locked in a crystal lattice, while hydrogen atoms flow freely like a liquid. This phase of water has only been created in laboratories for microseconds. GJ 1214b might have oceans of it. Planet 4, Tres 2b, iterations of it. The darkest object in the universe, distance 750 light-years from Earth. The problem, this planet reflects less than 1% of light. It's darker than coal, darker than black acrylic paint. It shouldn't be possible for a gas giant to be this dark. Most gas giants are reflective. Jupiter reflects 52% of sunlight. Saturn reflects 47%. Even hot Jupiters, those orbiting close to their stars, typically reflect 10 to 20% of light. Tres 2b reflects less than 1%. It's the darkest known planet in the universe. If you could see it, it would appear as an absence of light, a black sphere silhouetted against space. But here's what makes no sense. Gas giants are mostly hydrogen and helium. These elements are reflective. Jupiter looks bright because its clouds reflect sunlight. Tres 2b orbits very close to its star, closer than Mercury to our Sun. It should have reflective clouds of silicates or other compounds. Instead, it absorbs almost all light that hits it. The leading theory is atmospheric chemistry we don't understand. The planet is 1,800 degrees Fahrenheit, hot enough that compounds like titanium oxide and vaporized sodium can exist in the atmosphere. These chemicals might absorb visible light instead of reflecting it. But the concentrations required would be extreme, and we don't know how these chemicals would remain stable at those temperatures and pressures. And there's another mystery. The planet glows. Despite absorbing almost all visible light, TRES 2b emits a faint red glow. It's not reflected light. It's thermal emission from the extreme heat. The planet is so hot from absorbed starlight that it glows like a hot coal. This creates a terrifying image, a pitch-black sphere with a deep red glow, like something out of science fiction. Except it's real, and we can't explain it. Planet 5. HAT-PES 7 Bine Bay. A planet with sapphire clouds distance 1,044 light-years from Earth. The problem? This planet has clouds made of corundum, the mineral that forms rubies and sapphires. And the clouds move in the wrong direction. HAT-PES 7b is another hot Jupiter with extreme conditions. Temperatures reach 4,900 degrees Fahrenheit on the day side. Aluminum and oxygen vaporize and combine in the atmosphere to form corundum particles, the same compound that makes rubies and sapphires on Earth. These particles condense into clouds. This planet has literal gemstone weather. But here's the impossible part. On Earth, wind moves from high pressure to low pressure areas, and temperature differences drive this process. On HAT-PES 7b, astronomers observed something different. The hottest point on the planet, which should be directly facing the star, is offset. It's shifted to the east by about 10,000 miles. That means the cloud patterns are moving opposite to what physics predicts. The standard model says winds should blow from day side to night side. Hot air rises on the day side, creating low pressure. Cool air sinks on the night side, creating high pressure. Winds should flow from the high-pressure night side toward the low-pressure day side. That's basic atmospheric physics. Every planet in our solar system follows this pattern. HAT-PES 7b doesn't. Its winds blow in the opposite direction from day side toward night side. The shift in the hot spot proves this. Something is driving atmospheric circulation backwards compared to every other planet we've studied. Current theories suggest magnetic fields or extreme wind shear might be responsible, but the observations don't match the models. The planet is doing something our physics can't explain. Planet 6, WASP-18 by NIF, the planet that will die in 1 million years distance, 330 light-years from Earth. The problem: this planet orbits so close to its star that tidal forces should have destroyed it billions of years ago. But it's still here. And it shouldn't be. WASP-18b is 10 times the mass of Jupiter. It orbits its star every 22.6 hours, less than 1 Earth day. It's so close to the star that the orbital distance is only 1.2 million miles. For comparison, Mercury orbits the Sun at 36 million miles. This planet is 30 times closer to its star than Mercury is to the Sun. At this distance, tidal forces are catastrophic. The star's gravity pulls on the near side of the planet more strongly than the far side. This creates tidal bulges. The planet gets stretched into an oval shape. These bulges create friction as the planet rotates, generating heat and slowing the rotation. Eventually, the planet becomes tidally locked. Then the tidal forces pull the planet closer to the star. Eventually, the planet crosses the Roche limit and gets torn apart. This process should take millions of years. The star is 600 million years old. By now, WASP-18b should have been destroyed centuries of millions of years ago. But it's still there. Astronomers calculate that at its current orbital decay rate, the planet will crash into its star in less than 1 million years, a blink of an eye in cosmic time. Here's the mystery. We're observing this planet at the exact moment before it dies. What are the odds? Billions of planets exist in the galaxy. We've observed thousands, and we just happened to find one in the final 0.1% of its existence. That's statistically improbable. Either there's something preventing the orbital decay that we don't understand, or there are many more planets in death spirals than physics predicts, or we're incredibly lucky. None of these explanations work. Why these planets break physics? Every planet on this list violates our models of planetary formation, atmospheric dynamics, or orbital mechanics. These aren't edge cases or measurement errors. These are direct observations that contradict established theory, glass rain, moving at Mach 7. Physics says the atmosphere should tear itself apart. A planet hotter than most stars. Physics says it should have evaporated millions of years ago. It is the darkest planet in the universe. Chemistry says gas giants can't be this dark. This one is sapphire clouds, moving backwards. Atmospheric physics says winds flow a specific direction. These don't. A planet in a death spiral for 600 million years. Orbital mechanics say it should be dead. It isn't. Here's what this means for astronomy. Either our fundamental models of planet formation are wrong, or there are physical processes we haven't discovered yet, or these planets formed through mechanisms we can't explain. Every one of these planets forces us to reconsider something we thought we understood. These aren't just weird planets, they're falsifications of our theories. In science, when observations contradict theory, the theory has to change. These 6 planets are demanding that change. We just haven't figured out what the new theory should be. The universe doesn't care about our models. It does what it does. These planets exist whether we can explain them or not. They're out there right now, glass raining sideways at supersonic speeds, iron falling from clouds, water compressed into impossible states, sapphire clouds moving in the wrong direction, darkness absorbing everything, and a planet spiraling toward destruction. They shouldn't exist. But they do. And that means everything we thought we knew about planetary physics is incomplete. The universe is stranger than our theories allow. And these mysterious planets are proof.